So now this is the continuation class for the realization structures for the FIR systems. So now up to now we have finished the direct form realization structure in the FIR system. Now cascade form. So cascade form realization for the FIR structure, also similar to the IIR structure, cascade form realizations. So now here h of z is a transfer function. So cascade form means it is we should convert this h of z into a form like product of transfer functions. Each transfer function may be either first order, second order form. So here if I take like this, product of k 1 to L hk of z, that means there are L factors, right? L transfer functions. Then here hk of z is nothing but, if it is a second order form, it is a second order transfer function. So consider like this, bk0 plus constant or coefficient bk1 z power minus 1 plus bk2 z power minus 2. Okay. So generally h of z is nothing but, for the FIR system, it is the summation here already given in direct form. What is that? 0 to n minus 1 h of k x of n minus k y of n. And then here transfer function h of z is summation h of n z power minus n. Okay. So that's why here summation h of n z power minus n. Here n is equal to 0 to n minus 1. If you substitute this one, so here how many what is that how many terms are there here? From 0 to n minus 1, n terms are there. But so if you observe z power minus n term here, so last term consists of h of n z power minus of n minus 1. That means here what is the order of this equation? So here z power minus of n minus 1 is there, that means n minus 1 order. So here these factors, that means here we have to develop multiple of individual transfer functions from this equation. We have to find out the factors from this equation. Here this equation consists of n minus 1th order of z value. So here capital N is capital N. That means here factorization depends on capital N. Capital N may be either odd or even. If n is odd, for example, if n is odd, for example 9, right? So that means here we have the 10 terms, what is that, 9 terms, but here polynomial order is z power minus of n minus 1 means z power minus of 8. So here z power minus of 8 means how many second order transfer functions we will get from this 4 second order polynomial equations or transfer functions we will get. So that means here if n is odd, we can get the L second order factors, that is nothing but n minus 1 by 2. N minus 1 by 2, that means n minus 1 by 2. So in this example 8 by 2, 4. N minus 1 by 2 second order factors. If you consider first order factors, overall 8 first order factors. If you take second order factors, here 4 second order factors. That's why here if you consider n is 1, n is odd here in this case. So n minus 1 by 2 second order factors will be formed. So now each second order factor can be realized with the direct form. Okay, so now take this example here. X of n is there. So now cascading connection means, of course you know that here we should develop the direct form for this h1 of z. For the second one also, here realize with respect to direct form. Similarly here, how many terms here? Like this, hn minus 1 by 2 of z. Am I correct? So that means here, if you consider second order factors, there are n minus 1 by 2 second order factors are there. Okay, if n is odd. So now, what is the h1 of z here? Place k is equal to 1 here. What is that? b10 plus b11 z power minus 1 plus b12 z power minus 2. How can you realize this equation here? So see this. Here is k x of n, and then here, and of course you know that this one is nothing but y of z by x of z. Y of z is equal to x of z into this one. So x of n means x of z, that is multiplied by the bk0. Now second order means 2 delays, z inverse, here also z inverse. So here you can get the z inverse x of z, here you can get the z power minus 2 x of z. So z power minus 1 x of z is multiplied by the bk 1. Here k is 1. Here k is 1. b10, b11. Here, what is the multiplying factor? b12. Now, add all these terms in this way. Add these two. Add these two. So then you can get the b10 plus b11 z inverse plus b12 z power minus 2 into x of z as a output here. Okay, right. Now this one is cascading with the x2 of z. h2 of z is nothing but b20, then here use delay units, and then here take multipliers similar with the previous case. So now here b2 1, b2 2. Now here is here bn minus 1 by 2 0, bn minus 1 by 2 1, bn minus 1 1 by 2 2, z power minus 1, z power minus 1. Here y of n. Okay, this is the cascade form realization of the FIR system under the case capital N is odd. Okay, now coming to the another one, that is n is even case. If n is even, second case, if n is even. If n is even, so z power minus of n minus 1 order is there. That means z power minus, if n is 8, if you consider this example, 7. So z power minus 7, order is 7 here. Order 7 means, so how can you decompose this one into different factors? So how many second order factors will be possible here? 3 second order factors. So hence power 6 is over, left is only power 1. That means 1 first order factors. Am I correct? That means 3 second order factors, 1 first order factor. So similar way here, if n is even, right? So n by 2. So here see this one. See this one. 8. 8 means here n by 2 means 4. So in this 4, the first one is actually, so that means here actually 7. That means 3 second order factors, 1 first order factor. That means here, if I consider like this, n by 2, 8 by 2, 4. That means first one is nothing but first order factor. 3 means, remaining 3 means 3 second order factors. In such a way, I just rewritten this h of z like this. See this. So now first single order factor, let it be b10, b11, z power minus 1, right? Remaining all second order factors. How many here? From 2 to n by 2. 2 to n by 2. bk0, bk1 z power minus 1, bk2 z power minus 2. Okay, right? So in this way, we just decompose our h of z like this. Okay, right? So now, so how can you develop this one? How can you realize this one? See here, x of n. First place this first order factor. So here is a multiplier b10. Now use the delay unit, then multiplier b11 and then add here. Then the first term realization is finished. Now coming to the next part. Now the same way, second order factor as said in the previous case. Z inverse, B20, B21, B22, right? Second term also over and so on up to, what is the last term here? Bn by 2, 0. Bn by 2, 1. Bn by 2, 2. Here y of n. Okay, right? So this is nothing but cascades from realization structure for the FIR system when n is even. Okay.